Hello, we'd like to start by thanking the organisers for inviting us to speak at this session and thank you for choosing this talk to listen to. I'm Annegaaike Leopold, regulatory ecotoxicologist at Calidra's Environment and adjunct professor at the University of British Columbia in Canada.
And I'm Gunilla Öberg, professor at UBC in Canada and also part-time professor at the University in Bergen, Norway. Before we continue, I would like to recognize that I'm recording this from what now is known as Vancouver, which is on the traditional and unceded territory of the Coast Salish peoples. With that, I hand over to Annegaaike.
Thank you, Gunilla. Let me see if I can start this off. After working in the contract lab business for 25 years, convinced that by following the rules of GLP, I was being truly objective, I started to become very concerned and intrigued at the same time by persistent and sometimes indecorous things that scientists would say about other scientists. I would guess that you've all come across this at some point or another. After studying the topic more, I came to realize that instead of being truly objective, I was actually rather biased. And that this is not only true for me, but for everyone. And what is perhaps worse is that while we are blind to our own biases, we see them very clearly in others, and this fuels controversies. It has been quite an awakening.
It's undeniable that chemicals management relies heavily on input from science, but there is a large gap between science and policy, leading to less effective policies. When scientists disagree, it's commonly assumed that more research eventually will lead to that experts come to an agreement about how things work. The regulatory process surrounding chemicals management rests on this idea. Science advisors are expected to present a consensus view. In complex areas such as environmental toxicology, there are a lot of things that are uncertain. And when things are uncertain, different scientists come to different conclusions, at times even based on the same data. There's nothing fishy in that. Different disciplines approach problems in different ways, and they give different weight to different types of evidence. To expect scientists of different backgrounds who use very different approaches to come to consensus when there are large uncertainties is bound to be a challenging, if not impossible, task. We are concerned that it's not only challenging to produce consensus, but it might also be a problematic approach when dealing with complex issues surrounded by large uncertainties.
We wish to underline that it is a given that high quality science should be prioritized over poor quality science. There's no doubt that we have to find processes that ensure that the research that is allowed to impact policy is relevant and reliable. Over the past years, there's been tremendous development of various tools that help to strengthen the rigor of the winnowing process. This is an excellent development, but it is not enough. As Gunilla mentioned, when there are large uncertainties, even scientists who conduct high quality research can arrive at different conclusions. Our research suggests that the expectation of consensus leads to scientists being forced to fight to have their voices heard. Our fear is that the winnowing process will prioritize some scientific perspectives over others, leading to potentially valuable scientific perspectives being silenced. Not because studies from these perspectives were poorly conducted or biased, but because they were silently excluded. This might seem dramatic, but let us explain.
Let's go back to the beginning of our talk, the fact that we are all blind to our own biases, but hypersensitive to the biases of others. Even though we all, at least the majority of us, honestly do our best to conduct rigorous, reliable, and relevant research. This means that those who win in the prioritization process honestly believe that they are the last man standing because their way of interpreting things was right. That the studies that were excluded because they were wrong or not relevant or poor quality, biased, driven by ulterior motives, or even corrupt. I would think everyone listening to this talk is familiar with the paradigm concept. The idea developed by Thomas Kuhn that science develops through thought revolutions. This happens now and then. But it is more common that a revolution never happens, but instead different explanatory models, concepts, and theories exist side by side. This is because incommensurable ideas can at times be useful for different things. Take the electron models. At times, it's more useful to see them as a particle, and at times it makes more sense to see them as a wave. One of my favorite books is The Construction of a Scientific Fact by Ludwig Fleck. It was written already in 1936, so he predates Kuhn. In this book, Fleck coins the concept of thought styles, which he uses to describe that different groups of scientists or thinkers don't understand each other because their thinking is so different, so they cannot communicate. We all form thought collectives, which to my mind is very similar to what Karin Knorr-Sutina calls epistemic communities. What we take from Fleck is that different groups of scientists understand things in different ways. They think in different ways, and they see the problems in different ways. The only way to reach consensus in a group that consists of people who belong to different thought communities is to reduce the number of thought collectives in a group to 1. This is dangerous, because when it comes to handling complex and messy problems or wicked problems, the fact is that all solutions to such problems have unintended consequences. When formulating policies, it is therefore extremely important to choose solutions that are robust, making it possible for several perspectives to coexist throughout the evaluation process will increase the ability to foresee some unintended consequences and, perhaps more important, strengthen the capacity to handle them.
So, where do we go from here? Our research suggests that the factors that currently drive the winnowing process are not apparent even to those who are involved. As we're all blind to our own way of thinking, it won't work to simply tell science advisors to become more aware. Instead, we need methods, processes, tools to make the winnowing process more robust and transparent. We also need to find ways to make it possible for the regulatory process to consider several scientific perspectives. Identifying factors that make it difficult to reconcile different perspectives is essential. For example, something I have experienced during OECD working group meetings on guideline development. Halfway through the process, the group gets bogged down in dissent. My fellow workgroup member and friend, Tim Springer, calls this phenomenon starting in the middle of the problem, assuming but not ensuring at the start that everyone has the same notion of the concepts and terms that we're going to use. Recognizing the importance of this is a first step in addressing it. We are, of course, not the first to say this. Chief science advisors to the European Commission provide panel deliberation techniques to mitigate the risk of cognitive bias and arbitrariness in expert consultations. For example, they recommend how to select the experts. They suggest a balance between early career and established experts using novel selection criteria. They also recommend that when legitimate differences in scientific views cannot be resolved, they should be clearly identified and reported in evidence reports. In closing the gap between science and policy, SETAC is uniquely situated with its tripartite membership and representation from NGOs. This rough graph, based on SETAC's Global Horizon Scanning project, shows that about a third of the questions that SETAC members prioritized are related to policy and regulation. And as you know, SETAC members have organized a number of workshops that have led to policy developments. So we're doing very well overall. However, increasing calls are made from different stakeholders for SETAC and its members to do more to ensure that this knowledge is usable. At a discussion forum in May, all 3 members of the tripartite panel emphasized that to make sure the research output is useful, it is necessary to bring about a deeper understanding of the context where the knowledge is to be used, implying that scientists could or should collaborate more with social scientists and humanities scholars. If some of us in SETAC indeed do get more involved in these types of interactions, we will find ourselves increasingly involved in complex deliberations. This strengthens the call we're making in this talk for methods, processes, tools to increase robustness and transparency in the winnowing process when deliberating complex issues related to chemicals evaluation.
Scientists are trained to criticize others. That's what we do for a living. We critically review and express our opinions about the quality of papers, proposals, job applications, promotion, tenure files ad infinitum. There's also a strong tendency, particularly in academia, to poo-poo other approaches than those we favor. Modelers make jokes about lab scientists, who make jokes about those who go out in the field, who make jokes about modelers. Analytical chemists make jokes about synthetic chemists, and on it goes. We have been taught and learned to defend our own way of doing things and have rarely been encouraged to see the benefits of other perspectives, far less to applaud them. We need to get better at recognizing the value of perspectives that are different from our own. We hope that our talk has raised your awareness of the dangers of forced or manufactured scientific consensus, that there's an urgent need to strengthen the utility of science for policy. We also hope that you see that SETAC is uniquely positioned to take on this challenge. Thank you for your attention.